Hi, good day. Let us learn about lens-mirror equation. How would you describe the image in this figure? It is a real image because the rays actually converge at the point where the image is located. It is inverted. The object O1 is above the axis, but the image point I1 is below the axis. The image is reduced in size. It is smaller than the object. Thus, the image is real, inverted, and reduced. Where is the image? If the object is beyond C, as it is in this figure, the image is between C and F. If the object is moved outward from C, the image moves inward toward F and shrinks in size. If the object is brought closer to C, the image moves outward from the mirror. If the object is at C, the image will be there also, and it will be the same size as the object. If the object is moved even closer to F, but not inside it, the image will move further away and become larger. All features of the image can be found mathematically. You can use geometry to relate the focal length of the mirror to the distance from the object to the mirror, d sub O, and to the distance from the image to the mirror, d sub I. The equation for this is called the lens-mirror equation. This is the first equation you have seen that contains the inverses of all quantities. You should first solve this equation for the quantity you are seeking. For example, if you are given the object and image distances and asked to find the focal length, you would first add the fractions on the right side of the equation using the least common denominator, d sub I, t sub O. Then take the reciprocal of both sides. So we have f is equal to t sub I times t sub O over d sub O plus d sub I. Another useful equation is the definition of magnification. Magnification M is the ratio of the size of the image HI to the size of the object HO. By using similar triangles in a ray diagram, you obtain the following. Magnification M is equal to negative d sub I over d sub O. You can write a single equation for the image height in terms of the object height and the image and object distances by equating the two preceding expressions. The right side of each equation equals the magnification M, and therefore they are equal to each other. In the case of real image, d sub I and d sub O are both positive, so h sub I will be negative. This means that the magnification is also negative. When the magnification is negative, the image is inverted. What is the magnification of a plane mirrors? Recall that in that case, d sub I and d sub O have the same magnitude, but the image is behind the mirror. Therefore, d sub I is negative and the magnification is positive 1, which means that the image and the object are the same size. When solving problems involving mirrors, you may be asked to locate the image by means of a scale drawing using the method of the problem-solving strategy. At other times, when you are asked to find the image mathematically, you should also make a careful sketch to enable you to visualize the situation and check the reasonableness of your results. For example, a concave mirror has a radius of curvature of 20 centimeters. An object 2 centimeters high is placed 30 centimeters from the mirror. Where is the image located? How high is the image? Sketch the situation and locate the object and mirror, and then draw two principal rays. After sketching the problem, calculate your answer. What are the known quantities and unknown quantities? The known quantities are h sub O is equal to 2 centimeters, d sub O is equal to 30 centimeters, r is equal to 20 centimeters. The unknown quantities are d sub I and h sub I. Focal length is half the radius of curvature. Use lens mirror equation to find image location. So we have f is equal to r divided by 2. Therefore, the focal length is 10 centimeters. Using the lens mirror equation, 1 over f is equal to 1 d sub o plus 1 d sub I. So, d sub I is equal to f times d sub o all over d sub o minus f. Let us substitute the given quantities. D sub I is equal to 10 centimeters times 30 centimeters all over 30 centimeters minus 10 centimeters. The distance of the image is 15 centimeters. Use magnification relations to find height of image. M is equal to h sub I over h sub o and is equal to negative d sub I over d sub o. So h sub I is equal to negative d sub I times h sub o all over d sub o. Let us substitute the given quantities to find the height of image. H sub I is equal to negative 15 centimeters times 2 centimeters divided by 30 centimeters. The height of the image is equal to negative 1 centimeter. Check your answer. Are your units correct? All distances are in centimeter. Do the sign make sense? Positive location and negative height agree with the drawing. Are the magnitudes realistic? The magnitudes agree with the drawing. If this is your first time watching my videos, make sure you hit the subscriber button. Thank you for watching.